It is desired to remove the spike from the timber by applying force along its horizontal axis. An obstruction A prevents direct access so that two forces, one 1.6 kN and the other P, are applied by cables as shown. Compute the magnitude of P necessary to ensure a resultant T directed along the spike. Also find T. Here this is the spike and the two force, one is P and other is 1.6 kilonewton. Let's say the force P makes an angle theta 1 with the horizontal and force 1.6 makes an angle theta 2 with the horizontal. So the component of P along horizontal direction is P cos theta 1, and for perpendicular direction this is P sin theta 1, and for 1.6 kilonewton the component along this perpendicular direction is 1.6 sin theta 2, and along horizontal direction is 1.6 cos theta 2. Now let's say this point is O and this point is M, N, and this is, let's say, K. Now from the triangle O M N, Mn is equal to 100 millimeter, and here On is 200, this is 200 millimeter. So hypotenuse, that is OM, is given by root over 100 square and 200 square, and this is 223.6, and for triangle ONK, here ON is 200 millimeter and NK is 150, NK is 150 millimeter, this is millimeter, and OK is root over 200 square plus 150 square equal to 250. Now here the resultant force is directed along the spike, so the vertical component of the two forces are equal and opposite to each other, that is P sin theta 1 equal to 1.6 sin theta 2. So P equal to 1.6 sin theta 2 by sin theta 1. Here sin theta 2 is given by the triangle ONK. This is the angle theta 2, so this is the height and this is the hypotenuse. So the value of sin theta 2 is height. Here height is 150 and hypotenuse is 250. So this is 150 by 250, and the for sin theta 1, here height is, for the sin theta 1 here height is 100 and hypotenuse is 223.6. so sin theta 1 is 100 into 223.6. so after calculation, value of P is 2.146 kilonewton, and we see that the resultant force T directed along the side, and the total force along horizontal direction is given by T is equal to P cos theta 1 plus 1.6 cos theta 2, P cos theta 1 plus 1.6 cos theta 2. Here value of P is 2.146, and for cos theta 1 base is 200 and hypotenuse is 223.6 plus 1.6 cos theta 2. Here base is also 200 and height is and hypotenuse is 250. After calculation, the total value of T is 3.2, and this is directed horizontal to the spike, 3.2 kilonewton.